Hi guys, welcome back to my channel. Today I would like to discuss the solution for the differential equation question from the October-November 2013 paper, Cambridge A-Level Math 970932. So let's quickly get into the question. So this is the question you're looking here. This total question is, it has a total of 11 marks. So we shouldn't take more than 11 minutes. So let's see. Whenever you're dealing with the differential equation question, see that you read the question completely and you understand it, what is given and how you're going to approach it. So here the tank containing water is in the form of a cone with vertex C. The vertex C and the axis of vertical, semi-apical vertical angle is 60 degrees. So this angle is given as 60 degrees. At time t, the tank is full, which means the volume is full. It has a full volume of the water and the depth of the water is h. So the height is completely from the top to the bottom is capital H. At the instant a tap at C is open and the water begins to flow out, the volume of the water in the tank decreases. So here the volume of the water decreases at a rate proportional to root H. So what this tells us is that dV by dt is proportional to root H. Therefore, dV by dt equal to, since it's decreasing, you put a negative and a constant k root H. So that is the expression for the dV by dt. The tank becomes empty when t is 0. That means when t is 60, when t is 60, the height, the small h becomes 0. Also, the initial condition is when t is 0, your small h, since the tank is full, the depth of the water is completely in the full cone, so small h will be equal to capital H. So these are the two conditions we need to implement later. Now, the first part of the question is show that h and t satisfy the differential equation of the form dh by dt equal to minus a times h to the power minus 3 by 2. So let's see how we can do this. Also, v equal to 1/3 pi r square h is given. Now, if you look at the triangle, if you consider this is a radius r and this already given as h, so this forms a small right triangle. You can use SOHCAHTOA. So tan 60 degrees equal to r by h. Therefore, tan 60 degrees value is r equal to h times tan 60, and tan 60 value is root 3. Therefore, r is root 3h. We're going to use this condition in this volume expression v equal to 1 by 3 pi r square h. So v equal to 1 by 3 pi, r is root 3h whole square times h. That gives you 1 by 3 pi into 3h square times h. 3 cancel. Therefore, it is pi h cube. This is your v. Now, when we differentiate this volume with respect to time, we get dV by dt equal to pi times 3h square times dH by dt. So this is an equation A. Also at the top, we framed another equation, which is, let's say that is B. So dV by dt is minus k root h. If you see here in both these equations, you're talking about the same subject, which is dV by dt. So equate these two equations. So 3 pi h square dH by dt equal to minus k root h. Therefore, dH by dt equal to minus k by 3 pi. Combine the h's, which is nothing but root h by h square. So that will give you minus. And if you consider the entire constant k by 3 pi is a, so here you get h power half minus 2, which is h power half minus 2, and that will give you minus h minus a h to the power minus 3 by 2. Remember the rule, h power half by h square is h power half minus 2, therefore h power minus 3. And also remember, a here in this case is nothing but plus k by 3 by. this is the first part you need to prove. The second part is solve the differential equation given in part 1 and obtain an expression for t in terms of h, which means you should get t as a subject, and on the right you will be getting an expression in terms of small h and capital H. So let's see how we can do that. So we got the equation, differential equation dv dh by dt equal to, now use the exact value of a, which is k by 3 pi h power minus 3 by 2. Before you integrate, we need to separate the variables. So let bring the h power minus 3 by 2 on the other side. Get dh by h power minus 3 by 2 equal to minus k by 3 pi times dt. So this gives you h power 3 by 2 dh equal to minus k by 3 pi dt. Integrating on either side, since you have now separated the variables, you get h power 5 by 2 by 5 by 2 equal to minus k by 3 pi. Integrating 1 with respect to 2 will give you t plus c plus c. So this gives you 2/5 of small h to the power 5 by 2 equal to minus k by 3 pi t plus c. Now we have the conditions when t is 0, small h is capital H. So this becomes, use the condition t is 0, h equal to capital H to the power 5 by 2. This becomes 0. Therefore your c is 2/5 of capital H to the power 5 by 2. So now what we got is 2/5 of small h to the power 5 by 2 equal to minus k by 3 pi t. The c value now is 2 by 5 capital H to the power 5 by 2. Now let's use the condition when t is 60, small h is 0. So this becomes 0 minus k by 3 pi t is 60 plus 2 by 5 h to the power 5 by 2. So 3 divides, I'm sorry, t is 60. So 3 divides 60 20 times. Therefore, when you move this to the other side, you get 20k by pi equal to 2/5 of capital H to the power 5 by 2. And you're looking for k value. Therefore, your k will be equal to, so 2 pi by 5 into 20 capital H to the power 5 by 2. 2 divides 20 10 times. So this gives you pi by 50 h to the power 5 by 2. Therefore, our final equation is 2/5 of h to the power 5 by 2. It is minus k. So now k is pi by 50 h to the power 5 by 2. K by 3 pi. That's what I've been doing. So k by 3 pi plus 2/5 of capital H to the power 5 by 2. Now on simplification here you get pi cancelled. So this becomes, there's also t here. Please not forget. So minus h to the power 5 by 2 by 150t plus 2/5 of h to the power 5 by 2. And this is 2/5 small h to the power 5 by 2. Now looking for t, so get this term. So you get 1 by 150 h to the power 5 by 2 t equal to 2 by 5 capital H to the power 5 by 2 minus, when you move this to the other side, minus 2/5 of small h to the power 5 by 2. Take out the 2/5 common. So you get capital H to the power 5 by 2 minus small h to the power 5 by 2. And this is equal to 1 by 150 capital H to the power 5 by 2. So when you take these terms to the other side, you get t equal to 2 by 5 into 150. You can h power 5 by 2 minus small h to the power 5 by 2 by capital H to the power 5 by 2. And this gives you 5 divides 150 30 times. You get 60. Now split this. H to the power 5 by 2 by h to the power 5 by 2 minus small h to the power 5 by 2 by capital H to the power 5 by 2. So you get 60 into 1. This cancels off. 1 minus h by h to the power 5 by 2. And this is the solution for t in terms of small h and capital H. Now, let's look at the last part of the question. Find the time now when the depth is half h. So in this case, what you're going to do is you have when small h is half h, we're looking for what t is. So plug in the small h equal to uh, half h. So you get 60 into 1 minus half h by h to the power 5 by 2. So here you see h and h cancels. So you get 60 into 1 minus 1 by 2 to the power 5 by 2. So putting this in the calculator, 60 into 1 minus 60 into 1 minus 1 by 2 to the power 5 by 2. That will give you 49.3933. Rounding this will giving to, three significant figures, you get 49.4. So that is a solution for this differential equation question. Um, if you like our channel, please subscribe and give a like. Thank you.